In this video, we're going to talk about carboxylic acid naming. And so it's a new functional group. We're going to introduce a carboxylic acid is any kind of alkyl chain, so carbon, hydrogens, whatever we need, to a carbon, double bonded to an oxygen. That same carbon goes to an oxygen, which goes to a hydrogen. So this is a carboxylic acid. So carboxylic acids are the natural organic acid. That hydrogen is actually acidic. It can leave as H+. The oxygen is attached to ends up O-. You end up with a carboxylate. So if you remember your polyatomic anion names, 8 as a suffix was a polyatomic anion. Well, so these are used all over in biology anytime you need to create an acid or you want something that will be minus charged in normal pure water. Carboxylic acid will give away its H+. So they're useful and they get used for a lot of reactions as well. But this is the general structure of a carboxylic acid. And the ending that we use for this functional group is oic space acid. We really want people to know it's an acid, so it's in the name. So let's do an example then. We have, we'll go for the starting one here. So if we look here, I have 1 carbon, 2 carbon, 3 carbon, 4 carbon. Now the carbon that's part of the functional group, well, that's always going to be carbon 1 because we need our functional group to be as low as possible, and that carbon is always where it's always going to be on the end of the chain because, well, you can't have another carbon going past it. You have that OH in the way. And so this is always carbon 1, carbon 2, carbon 3, carbon 4. So in this case I have a 4-carbon chain, so it is a bute chain. Carbon-carbon bonds are all single, so it is a butane. And it is a carboxylic acid, so it's a butanoic acid. Butanoic acid. So we don't tend to put 1 in, like you could say butane 1-oic acid, but they have to be at position 1. If you have multiple, you have to put where they are, but the carboxylic acid always has to be at position 1, and so we don't usually bother putting in 1. Counterexamples of that then would be, let's do one with 2. So same basic shape. Let's do this. And give this a shot. Go ahead and pause. See if you can name this and then come on back. Alright, give it a shot. Well, if we look, there's still 4 carbons. So here's a carbon, there's a carbon, there's a carbon. So we're still some kind of bute chain. But this time I have 2 carboxylic acids. So I have to figure out how do I number these. Well, one of them is going to be 1 and the other is going to be 4 no matter which direction we go. So it's irrelevant since there's nothing else. No matter what you do, it's a 1 and a 4 position carboxylic acid. So if we want to name it, well, it is a bute again. So bute for the carbon chain length. The carbon-carbons are all single bonded, so butane. And this time I have 2 carboxylic acids. It's going to be a dioic acid, and I need to tell you where. So 1,4 dioic acid. So butane 1,4-dioic acid. You'll notice in my early example I actually drew the OH bond, but in these later ones we just put the O right next to the H. That is to still indicate that a hydrogen is attached to the oxygen, but it's just a shorthand for when you put hydrogens onto heteroatoms. So remember, on carbons we don't show hydrogens, but on any other functional group we have to show any hydrogens present. And often we don't bother drawing the bond. So whether that's carbon OH or whether that's HO carbon, You can write either one either direction. You just want to make sure the carbon and the oxygen are connected and then the hydrogen and the oxygen are connected. So let's try a little bit of naming. Let's try these two. So go ahead and pause, give both of these a shot, and then come on back. All right. Well, if you gave it a shot, let's work our way through it. So our first one over here, 1, 2, and then either direction is going to give us 3 carbons. So our chain length is 3, and I have a methyl subgroup that's unattached. So this is prop for being 3 for our main chain. They're all single bonded carbon to carbon, so it is a propan. And then it is an oic acid. It is a propanoic acid. It has a methyl at the 1, 2 position. So there is a 2-methyl propanoic acid. And so 2-methyl propanoic acid is our left molecule. If you want to go look at the right, well, my carboxylic acid is my functional group. So here's a carbon for it. It's going to be carbon 1. Here's my next carbon line. It's carbon 2. And then, oh, I hit a ring. Remember, you can't have a chain go into a ring. We can't start counting the ring carbons. You either name as a ring or you name as a chain. So this is a subgroup. It's a 4-carbon ring. It is a cyclobute, and then it's a subgroup, so it is YL, cyclobutyl, and it's at the 2 position. So it is a 2-cyclobutyl for the subgroup. Our main chain is 2 carbons long, so it is an eth. They're all single bonds between the carbons, ethanoic acid, and we have our 2-cyclobutyl. It is a 2-cyclobutyl ethanoic acid. And that is how we name carboxylic acids. Oic acid is the suffix to represent them. They are a carbon double bonded to one oxygen, and that same carbon single bonded to an oxygen that goes on to a hydrogen. So this is our carboxylic acid.